Hello, hello. Welcome back to Math Made Possible. I believe I can. I'm your current teacher, Miss Howard, and today we're going to be using the fifth grade illustrative math curriculum to do a summary for our Unit 2's Lesson 11. All right, so I'm going to try and go slow today because this involves a lot of work. And I want to make sure that everybody understands because we're still going to be finding areas of rectangles, but it's a progression. So, uh, lesson 9 was where we multiplied whole numbers by unit fractions. Those were fractions with the number 1 above it. Lesson 10 was where we multiplied whole numbers by non-unit fractions. That's something like 5 times 2 over 3, right? Today, we're going to be looking at images like this. All right. So here's a few things that I want everybody to keep in mind. Take a look at this area right here. You see these brackets? These brackets are very important. It basically tells you where our hole is. So as you could see right here, this section right here represents one hole. So this is 1, and I'm going to just keep on typing. This would be 2. Oh, that doesn't work. Let's go ahead and make it a little bigger. That's 2. Nope, that still doesn't work. All right, we'll just write. So this is 2. This is 3 holes. This is 4 holes, right? And this is not a hole yet, right? This is 2/3. And if this is a hole right here, we see this whole side is all filled in. So this is basically, we're going to represent that with the number 4. Now, as you can see here, this says select all expressions that represent the area of the shaded region in square units. For each correct expression, explain your reasoning. All right, so let's start with our first one. It says 4 2/3 times 4. Well, I can choose that one because I see the number 4 right here, and we said that there were 4 holes right here with 2/3. So 4 plus another 2/3 right here. So that's definitely right. Now, this says 16. Let me see if I can find 16. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I don't see 16. Okay, so I'm going to say that's wrong. Let's see if we can find 16 someplace else. 1, 2, 3, 4, 5, 6. I'm just double checking my work. This is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay, so I can see where they came up with 16, but it's not times. We're not multiplying 8/3. Let's see what we have here. We have 1, 2, 3, 4, 5, 6, 7, 8. Well, that's definitely 8/3. So we have the correct numbers here, but this is 16 plus 8/3. So that's why this one is definitely wrong. Okay. And what I want you to do, guys, is definitely work it out. You have to work the whole thing out. Try and figure out where are they coming up with the numbers, right? See, the first time that I did it, I count each individual tile right here, and I didn't see 16. But guess what? When I counted all of the holes, that came with a hole of 16. So I saw their hole of 16, but 8/3, no, that's not what we found our 8/3, but it's not multiplied. It is added to it. All right, well, how can we find 14/3? Let's take a look at that again. Let me erase this work so that we can see it a little bit clearer. Now let's see if we can find 14/3, and let's see if we can find the number 4. Well, looking right here, I could see that my whole number of 4, and let me also change this and make this clearer because I want to make sure. I showed you it broken down before, but now let's label this side as 4 holes with 2/3. Now, I see 4 right here, so that's a check. Great. Now, can I see 14/3? Let's go back and count like we did in letter B. Let's see if we come up with 14/3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Awesome. And it is partitioned into thirds. So I do see 14/3 times 4. It's 14/3 there, 14/3 there, 14/3 there, and 14/3 there. Now, let's see if we can find 56/3. Wow, that's a big number. 56. So, what I can do is if I were to count all of these, would that equal 56? Well, if I know 14 is at the top, I could say 14 times 4. Let me see what that gives me. I know some of you might say, oh, I might want to do repeated addition. That's fine. But remember, you'll have to add 14 plus 14 plus 14 plus 14. And I don't want you to make any mistakes. So let's go ahead and go right to multiplication, which is the same as repeated addition. We know that 4 times 4 equals 16. And the 6 goes in the ones place and the 1 goes in the tens place. 4 times 1 equals 4 plus 1, that's 5. So that's absolutely right. We do see that these little tiles right here, if you took the time to count all of them, there will be 56 total tiles partitioned into thirds. All right. Now, can we find 4 times 5/3? Well, I definitely see my 4, but I don't see 5/3. If you wanted to look at it like this is not even 5/3. This is 4 holes, right? Okay, let's go on to our next one. Hopefully that helps out. Now, for these, we want you to actually write an expression 2 ways. And remember, pay attention to the bracket. This equals 1 whole. This equals 1 whole. So this whole side is not 1. It's actually, because there's a hole right here and there's a hole right here, this whole side is going to represent 2. And guess what? All of this is filled in and all of this is filled in. So that's 2 as our whole number. And only a 1 is shaded here, 1 out of 4. So that's 1/4. So the expression, one of the expressions that you could write is you can write 2 times 2 and 1/4. And I'm going to show you how to solve these in just a moment. Or I can write 2 and count each of these boxes for this first row. This first row, how many do we see shaded? We see 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would be fourths. So that would be 2. Ooh, let's make that look neater. That would be 2 wholes on this side times a total of 9 over 4 because it's partitioned into fourths. Let's work this one out. This one should be pretty easy. And whenever we're multiplying a whole number by a fraction, we put that 1 underneath it. 2 times 9, that equals 18. And over 4. And now we are going to convert it. So that would be a total. And we remember that whenever we see the fraction bar, that is a division symbol. That's just like division. So we're going to drop it into a long division bar. We ask ourselves, how many groups of 4 can I make in 18? That will be 2 wholes. 4 times 2. Oops, Miss Howard made a mistake. Hold on. 4. Sorry. Miss Howard. I'm going to show you everything visually in just a moment. I knew that did not sound right. You got to always ask yourself, does my answer make sense? And if it doesn't, you've done something wrong. Go back and double check, right? All right, that's with 2 left over 4. Now, let's do this side and let me show you how easy that was. This is 1 whole. This is 1 whole. This is 1 whole. And this is 1 whole. So that's 4 wholes. And if we brought this up here and shaded that in, so that means this would be crossed out because we moved it. So you see that we have 2/4 right here, also known as 4 and 1/2. That would be an equivalent fraction of that. Now let's take a look at this one. How would we solve it this way? Well, we can say 2 times 2. We know that 2 times 2, the two whole numbers, that will equal 4. And then we'll take our whole number again, and this time decompose the 2 and the 1/4, just break it apart, because that's the same as saying 2 plus 1/4. And so we could say 2 times 1/4. Excuse me, not half, a fourth. Always always double check that you're writing the correct information down. 2, let's go ahead and put a 1 underneath our whole number. And we know that 2 times 1 equals 2, and 1 times 4 equals 4. So our final answer here would be, after we add those numbers, that would be 2 and 2. And you see I wrote the number 2 and it's supposed to be 4. Hold on. Oh, that was from that. Hold on. So we have this 4 right here plus this 2/4. That's why I have different colors. That also helps out with your work if you're working on making sure that everything is organized. As you can see, my labeling is in one color and then my work is in another color, especially when I'm writing close to my work, right? So again, this side length is 2. This side length is 2 and 1/4. Then we're multiplying those two side lengths together, just like we did with our previous activities. We take our whole numbers out, multiply those together, that equals 4. And then we multiply our whole number side by the fraction side length. 2 times 1 equals 2. 1 times 4 equals 4. All right, let's try another one. All right, here's a harder one. Similar problem, we have a 1 whole right here, and that's 1 whole. We can identify all of our wholes at the top. That would be 1, 2, 3, and 3/4. So that's 3 wholes and 3/4. And we have 3 wholes at the side. So one of our expressions will be 3 times 3 and 3/4. Again, we can isolate our images. Another way that you could think about it is, do you remember back in 4th grade you learned the area model? And you have 3 at the side, and you have 3 up here, and 3/4. You know that 3 times 3 equals 9. And now 3 over 1 times 3/4 equals 9/4. And I am going to have to convert that, right? How many 4s can I make? How many whole groups of 4 can I make in 9? And I know that will be 2. 4 times 2 equals 8, with 1 left over. So that would be 2 and 1/4. And I add that 2 and 1/4 to my whole number of 9. Can't forget this whole number of 9. So that would be 11 and 1/4. Now let's go. All right, I wanted to come back and show you the second way that we can solve this problem. We could write an expression. We can also look at our bracket right here. This equals 1. So I see 1 whole piece right here, 1 whole unit right here. Let's not call it a piece, it's a whole unit. And 1 whole unit right here. That equals 3 wholes on this side right here. And we're going to use the other strategy that we used in our previous slide. And we're going to go ahead. Let's go ahead and use our highlight. We have 1, 2, 3, 4. We're just counting all of our little rectangle shaded tiles. And we're going to count all the way across. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So this whole section right here has 15 thirds. So yes, just like we said before, you can write 15 thirds plus 15 thirds plus 15 thirds. I prefer to go ahead and write our multiplication expression. So we're going to write 3 times, let's make that look neater. 3 times 15 thirds. Why don't you go ahead and work it out while I write? And hopefully we come up with the same answer. So I'm going to sit in silence You should be working it out on your own. Remember to put your 1 underneath your whole number. Don't ever forget that, okay? We know that 3 times 15 equals 45. 1 times 3 equals 3. Ooh, 15/4 is what we should have. Now we need to convert this. You could see 45/4 as an answer on your test. But if you see a mixed number answer, that's where you have to work it out. We ask ourselves, how many group of 4 can we make in 4? That's going to be 1. And we go through and go through with our subtraction. 4 minus 4 equals 0. And we're going to drop our 5. We ask ourselves, how many groups of 4 can I make in 5? And that is also 1. And 1 times 4 equals 4. 5 minus 4 equals 1. So our answer is also 11 and 1/4. Okay? Hopefully one of these strategies will make sense to you. I like this one because it's pretty easy to see the whole, count the holes on one side for one side length, and just count all of your shaded pieces. I mean, yeah, you might have a big number, right? Like a 3 times 15, but if you just line it up, you can solve that problem, right? 15 times 3, so you can get 45, right? Work it out in the way that you understand it, but make sure that you do choose this answer choice as one of the answers when you're writing your answers, choosing your answers for the test. Thank you so much for watching. I do appreciate you guys spending time with me. Hopefully, I didn't confuse you. Just rewatch the video and give me some feedback. If you're one of my students, just let me know, hey, Miss Howard, can you make video or explain it a different way in class, or do the same thing with your teacher? Watch other videos. All you have to do is search up Illustrative Math, Grade 5, Unit 2, Lesson 11, and you'll see other videos. Or you can search up multiplying mixed numbers by whole numbers, uh, fractions. All right. If you have not done so already, please don't forget to like and subscribe. And I will see you on our next video for lesson 12. Have a great one. Bye bye.